In this video, you'll see equation 2 done 2 different ways. Do a split screen.
All right, students, we're going to look at another approach to balancing chemical equations. It's just our way of making sure that all the atoms that we start with are the same atoms that we end with on the product side, because matter can't be created or destroyed, only rearranged. So, like any good balancing chemical equation approach, you want to keep track of what you are starting with at the very beginning. So I'm just going to underline each element. I've got 1 tungsten, 3 oxygen, 2 hydrogen on the reactant side. And I've got 1 tungsten, 2 hydrogen, and 1 oxygen on the product side. Now to see if they are balanced. Tungsten, yep, is balanced. Oxygen, no way. And hydrogen, actually, yes, also balanced. So if it weren't for that oxygen, we'd already be there, but we have some work to do. So remember that in balancing, you cannot change the subscripts. Don't change the subscripts, right, from that song? And so as much as we'd like to change that, these 3 oxygens to 1, we cannot. Those 3 oxygens are here to stay, because there's at least 1 of that molecule. So the only thing I can do is get more oxygens to show up on the product side. So in this approach, I'm just going to actually copy paste my oxygen molecule, because I also can't just add a subscript of 3 here, right? Can't change subscripts. So my only chance at doing this is just having more copies of that molecule. So here I've got 2 oxygens, so I guess I need 1 more water molecule in order to have 3 of them. Okay, but now that I have 3 of these molecules, I've also changed my number of hydrogens. So let's count these up again. Hydrogens, I got 2, 4, 6. Add them up just like algebra. Oxygens, I've got 1, 2, 3. Boom. All right, let's take a look at our balancing. Tungsten is balanced. Hydrogen is not. Oxygen is balanced. All right, we're closer. Remember, with these kind of things, it's always a back and forth. Sometimes you got to keep messing it up before it's perfectly balanced. Perfectly balanced. There we go. So we've got a bunch of hydrogens here, 6, but only 2 here. So let's go over here. Remember, we cannot change that subscript. And so the only thing we can do is just get more of this molecule altogether. So copy, paste. That would give me 4 hydrogens, but I think I need 6 if I'm remembering right. So let's add these up. 2, 4, 6 hydrogens. Let's see. This might be the golden ticket. Tungsten is balanced. Oxygen is balanced. Hydrogen is balanced. Boom, we nailed it. All right, now when people write chemical equations, they don't like the clutteredness of having to write this 3 times or this 3 times. And that's why we have coefficients. So instead of writing everything 3 times, I'm actually just going to put a coefficient here of 3 instead of drawing it multiple times. And same here for the hydrogen, H2, I'm going to put a 3 because we had 3 total. And so what your final answer would be, just be this in the orange box. This is your balanced chemical equation. Everything that we worked on down here is just us using our awesome strategies to make sure that our math was adding up and we really were fulfilling the law of conservation of mass. So hopefully this approach helps you. If not, just use a different approach. Different approaches help different students. Have a good one.
Let's try this one. First thing, underline and count. Here I see capital W, that's 1, and capital O with a 3, so that's 3. Capital H with the 2, that's 2. And on the other side of the arrow, capital W, 1, capital H 2, capital O 1. So I start on the left usually, and I see 1W, look at the other side, 1W. So for now, that's good. Now I'm going to look 3 O's, and on the other side, only 1 O. So that is not balanced. So I'm going to think about those O's, and I also might want to check and see I have 2H and 2H, and the O is going to change that, so I'll figure out what to do with H's as well. So I have less O's on the right side over here. So I'm going to add a subscript there, and since I need 3, I have to think about, I see 3 here, I need to think about how will I make this turn into a 3. So I need a coefficient of 3 because 3 times 1 is 3. Now remember, that will also change the H because they're a bonded molecule. So 3 times 2 is 6 for the H now, and 3 times 1 is 3 for the O. So now I need to fix those H's, and I see now on this side I only have 2 H's, and there are 6 over here now. So I have to think about what will I put here that will multiply by 2 to make 6, and that will be 3 again. So I will put a 3 in front here. And then I like to show below 3 times 2 is 6. So now I'm going to double check the W's, like starting from the left again. I see 1W, 1W, 3O, 3O. I'm looking at the totals. 6 H's, 6 H's. Those are the totals that I'm showing below. Looks good now.